Okay, now let's see, this is a topic on functions. But before we answer this question number one, let's go through a little bit of understanding of functions. So, for example, if you have a function, say for example fx is equals to 1 over x, and let's say x is bigger than 0. Now you see in this part the graph is something like this kind of pattern, right? So this side I don't need to draw because we already say x is bigger than 0. So that means this is called a domain. Okay, that's a domain. And then the range is the y value. What is the highest y value here? See, the highest it can go up to infinity, but this one can go close to 0, but it won't touch the x-axis. So in this case, the range is also y is bigger than 0. Alright, so this is 1 is to 1. 1 is to 1 function. 1 means because this one value of x goes to one value of y here. So that's why we call it 1 is to 1. Right? But let's say if you have another function, say y is equals to x square plus 1 for example, and let's say they give you x as a member of real number. This is the domain here. So if you sketch this graph, so you have a graph something like, let's say this is 1 here, so your graph would be something like this. Right? So this is y equals to x square plus 1, and it cuts at 1. Now this is not one-to-one function because you see here this x value will go to this y value. It's the same thing here, this x value here will go to the same y value. So this is many to one function, right? So in this case, what about the range? The range is, what is the lowest value here? Lowest value of y. So the lowest value of y is 1. So y is bigger or equals to 1. That is the range. And this one is, we already say, is the domain. So if the function is not one-to-one, like here is many to one, that means the inverse does not exist. Inverse does not exist. Okay, in this case the inverse does not exist. It must be one-to-one function. Like here, one-to-one function, the inverse exists. Alright, so let's say for example here, if you have fx is equals to say 1 over x plus 2, and then let's say I put x is bigger or equals to 1. So in this case, you see, if you draw the graph, it's just to get an idea, we draw the graph here, right? So 1 over x is somewhere, your graph should be going like that, 1 over x, but that is not we are interested. We are interested in 1 over x plus 2. So let's say this is 1 and this is 2. So you can say the graph will go closer to 2, but it will not touch 2. And this is called the asymptote line. Asymptote. So this is y equal to 1 over x, but they say x is bigger equal to 1. That means, in other words, you test the value when x is 1, y is equals to 1 over 1 is 1 plus 2, so equals to 3. So if this is 1 and this will be 3, that means 1 and 3 is, say somewhere here 3, so something like this. So this is your the equation. Okay, so now in this case, what is your range? So your range is y is smaller than or equal to 3 but bigger than 2, and that is your range, because it can go close to 2 but not equal to 2, right? So if you are looking for the inverse means, okay, let's say this is f minus 1x. If they ask you what is the inverse, so how to find that? Alright, so for inverse, we let, now there is different ways of doing it, but I'm just doing this way. Let y equal to 1 over x plus 2. Our aim is to find x in terms of y. So this is y minus 2 equals to 1 over x. Now this is also over 1. So I flip it around. This one is flip it around. So that means I have x equals to 1 over y minus 2. So from here, f minus 1 y equals to 1 over y minus 2. That means f minus 1 x equals to 1 over x minus 2. This step actually is not necessary, but it's just for discussion only. So f minus 1 x equals to 1 over x minus 2. Now if you draw the graph, now just now you already say x is bigger than 2, y is between 2 and 3. So for this, the range will become the domain. That means x is bigger than 2, smaller or equal to 3. And then domain will be, here you see x is bigger than or equal to 1. So y is bigger or equals to 1. That will be the range. So your f minus 1x is equals to 1 over x minus 2. So check your x is between 2 and negative 3, y is bigger or equal to 1. So if I sketch the same graph, that means this y is equals to f minus 1x. Okay, you can see here x minus 2 equal to 0. That means x is 2 is an asymptote. So x equal to 2 in asymptote means this is 2 here. So this will be the asymptote here. When x equals to 3, so f minus 1, 3 equals to 1 over 3 minus 2 is 1. So 3, this is 3 here, gives you 1. So somewhere here. Somewhere down here. So this is a point here. Alright. Now you also must remember both the graph, they can reflect on y is equals to x. Fx and f minus 1x, you can reflect on the line y equal to x. So it cuts at 3, that means your graph will be going, so because it cuts here also, this will be your graph. So here y is equals to fx. Alright, and this part y is equals to f minus 1x. Alright, so this is the point where the reflection is the same value. That means when this graph and this graph meets at this point, right? So reflection is on the same place, so there's no change. That means in other words, you can say f minus 1x is equals to fx also equals to x at that particular point. That means you are talking about this particular point. Okay, so that will give you some idea before we can start with the question. For more videos, please WhatsApp this number. We have plenty of videos, so in fact you can learn the entire subject through questions and the videos. You will send the questions, then after that we will send the videos. Thank you. Bye.